Data lineage is the process of tracking your data across its entire life cycle. Where it originates, either is captured or generated, how it moves through different systems, and what transformations it goes through. There are two primary ways that it provides value. First of all, compliance. In certain industries, especially in the financial sector, this is not optional. This is mandatory, and you are obliged to provide and ensure data lineage across the whole system. Another is productivity. Being able to instantly see where a given piece of data is coming from reduces a lot of the overhead connected to finding this information yourself. And once you track data lineage, you can build other more advanced capabilities on top of it, like data observability or other aspects of data quality. But while data lineage is quite well adopted in the analytical space, it isn't the case for the operational systems. There are good reasons for that. First and foremost, the diversity of systems used in the operational plane. Very often in large enterprises that have been around for a while, you'll see applications written in different languages, different frameworks, but also created in different times. That some projects have started a year ago, others have started 15 or 20 years ago. It's quite a challenge to find a common language that they can speak. Another is the complexity of providing advanced features of lineage, like column lineage or column summaries. Whereas data platforms are standardized, in the operational plane, when you write very custom logic, very often it's not as straightforward to provide column lineage without significant overhead. Today, I want to show you my attempt at providing table lineage for the operational plane using open source tools. And table lineage is a subset of data lineage to make this simpler. And I will be using OpenLineage as the language in which my components will produce lineage data. And I will be using DataHub as the consumer of these lineage events. And DataHub is, I think, the most widely adopted open source data catalog, which also has good OpenLineage integration. And the system that's publishing lineage is composed of Debezium, Flink, and a Java application. And all these are producing OpenLineage events that gets consumed and visualized as a lineage graph in DataHub. And as usual, all code is available on GitHub. The application is a simulator of an online web store where you can manage products, stores, and promotions through a web user interface and HTTP endpoints. And then there is a simulator simulating sales transactions. And all of this data gets joined and enriched in Flink SQL jobs that calculate real-time dashboards and sync them into Postgres tables so that they can be visualized in the UI again. I've already published videos about Debezium and Flink, and if you're curious, check them out. So today I'll focus on the Java application exclusively. And in the setup, we have two node types. One node type is an HTTP endpoint. Another is a Kafka listener. And when these endpoints get triggered, the node name gets put in the MDC context so that this can be processed by this setup. I also have interceptors registered in my JDBC data source and Kafka producer. So whenever any logic tries to change Postgres or Kafka data, this means that there was an operation that's worth registering, and it registers the lineage so that the components can publish the lineage event to DataHub. And this is the resulting lineage graph of one of the reports. We have 3 Postgres tables, and as you can see, each has an HTTP endpoint that modifies it. The simulator logic is publishing sales transactions to Kafka, but also reads data from store and product tables. Then we have the Debezium connector that moves all 3 tables to their respective Kafka topics. There is a Kafka listener in there that also uses 2 tables on top of the topic it's consuming from. And the Flink SQL streaming query is aggregating daily sales per product in real time and publishing the result to the Kafka topic, which is moved to the Postgres table by another Kafka listener. The data in this table is visualized in the UI with real-time updates. All of this is built with just configuration. There is no additional overhead per topic or per table. So how is this built? One of my goals was to provide a generic way so that this can be used in any Java application, not just in Spring. So I've split the project into 2 modules. One is the library that has almost all lineage-related stuff in it. It doesn't have Spring dependency. What's inside are the JDBC interceptor and 2 Kafka interceptors, plus the core lineage logic. Most importantly, the data model, lineage registry, and OpenLineage emitter. Then there's the Spring app with the domain logic, so stores, transactions, and so on, and configuration that demonstrates how you can set it all up. The HTTP interceptor is also there because the interceptor for HTTP endpoints will be dependent on the web framework you are using, and in my case, it's Spring Web. So why have I built it, and how can this be useful to you? I wanted to explore both OpenLineage and DataHub and data catalogs in general, because I'm very interested in other capabilities apart from Lineage of this class of systems. And on the way, I found many bugs. I fixed 2 bugs in OpenLineage and reported a few more in Debezium, Open Metadata, and DataHub as I was working on that. Almost all of them are fixed now. And how can this be useful? Well, all code is available, and when I'm working with something new, it's always helpful to see working examples, and this is one of the main reasons why I published the code. And as I said, data lineage is not really supported for the operational plane. Confluent Cloud has a really cool lineage setup, but it's limited to the streaming platform. And with what I've built, you can easily extend it to other types of databases or messaging systems. And when you are working with complex applications that I've worked with for many years, very often what you do is you maintain a diagram of the interactions between components of your system. And just having this integrated with your setup with very low overhead, it would provide significant value to the systems I've seen in the past. So I have built a basic core skeleton that can be extended, and you can build advanced capabilities into that. Also to see if there is interest in this, because if there is, I'm happy to extend the solution. But introducing all this makes sense only if you already are using a data catalog. And data catalogs are fantastic. They enable a new level of governance and data observability and discoverability. But DataHub especially is pretty heavy. Open Metadata is much more lightweight, but they don't have proper OpenLineage support yet, so this won't work with Open Metadata until this is fixed. Yeah, so that's all I have prepared for you today. Thanks a lot for watching. If you are interested in this topic, maybe other aspects of data lineage, maybe the capabilities of data catalogs, please let me know. I'd love to hear whether this is helpful in any way. So thank you, and see you in the next video.